So, you are planning an experiment, but you know that probably your measurements will not follow a normal distribution. Does that influence your plans? Let's start with the situation that your measurements are continuous or maybe integer with high values, not 0, 1, 2. Now, what if your data are not normally distributed? In case you are doing a t-test or an ANOVA, and for every treatment you have 30 or more observations, the central limit theorem ensures it will not be a large problem. You get reasonably reliable p-values. If you have fewer observations per group, we will need to think ahead. There are tests that can be done if the normality assumption is violated. Alternative for the one sample and two sample t-test is the Wilcoxon rank sum test. And for paired analysis with two measurements per unit, the Wilcoxon signed rank test. Alternative if you are comparing more than two treatments is, for example, the Kruskal-Wallis test. And a kind of paired analysis with more than two measurements per unit can be analyzed with the Friedman test. Remember that you now draw conclusions on medians, not on means. More options are available for specific situations. However, for more complicated designs, such as with two different types of treatment and interaction, no commonly used alternative is available. But there's a different option. In particular situations, transformation of your measurements can make the distribution normal. Commonly used transformations are the square root and the logarithm. This may solve your problem. Just remember that the interpretation of effect sizes and confidence intervals becomes different after transformation. If your data are ordinal, maybe poor, reasonable, good, excellent, Wilcoxon test or Kruskal-Wallis test may be suitable. A chi-square test can also be an option for this kind of data, depending on the situation. In all cases, think well about the interpretation. In some situations, permutation may solve the non-normality problem. It may, however, not be straightforward what you must permute and how, and it will require programming. In any case, it will require sitting down and working it out before you start your experiment. Designs with multiple interacting factors can be complicated to deal with. So, unless you have large samples or you can transform your measurements into a more or less normal distribution, your analysis options may be limited. In that case, you should probably not aim for an analysis with interactions or other complications. And you may want to have a relatively simple experimental design. If there is no literature and you have no option to do a pilot, you may have no idea what your measurements are going to look like. Many quantitative variables, fortunately, are more or less normally distributed or can be transformed to such. However, be aware that it can be different. If you have doubts, you can ask a statistician for advice, and do that before you start your experiment.